Okay, office hours, problem solving.
I have no idea what's going on. I have looked over it like 3 times, but I'm really like, I have no idea where to even start. And it doesn't look anything like Rice's theorem. Yeah.
For which problem? Any particular one?
All of them.
Yeah, problem set 5? Okay. Yeah, I don't think Rice's theorem can apply to any of them. Yeah, because I figured it's so easy comparatively that you should get practice doing the other way.
Got it.
Yeah, but Rice's theorem can be applied. It's just so easy. It's like 2 lines. Yeah, you had a question.
Well, it's not a hard one, right? Did you use the iPad version of Roller Coaster Tycoon?
I found it on the internet.
It looks like you are.
Yeah, I play it on my iPad all the
They
time.
put the, yeah.
Yeah,
I don't even know.
yeah, I know it's the classic.
Is that the full? I'm pretty sure it's the full version that used to be on the computer, right?
Mhm. They updated the UI a little bit. So. Yeah.
So to show that something is undecidable, we can do it 2 ways. We can use Rice's theorem if it applies, or we can use the reduction.
Yes.
So when we use the reduction, we have 3 things that we can use, like ATM, ETM, and EQTM. So how do you know which one to use?
There are other possibilities, like anything that that Rice's theorem says is undecidable, like infinite TM, for example, like the set of machines that have infinite language. By Rice's theorem, that's undecidable. So you could use that if you wanted to. So there are a whole host of problems that you can use, but the ones we covered certainly will work. Like we also showed that all CFG is undecidable, right? Because we did the accepted computation history for that. So it's not just those 3 of Turing machines. There are some other ones that you can use too.
So do you have to check the inputs that, because if you're trying to prove that something that just takes in a machine is undecidable, can I use ATM because ATM takes in a machine and a string?
Well, it's not at the right format then.
So it has to match the input.
Yeah, it has to match. Yes. Yeah.
So I understand that you can't really do too much talking about the problems. However, can you at least kind of give us an example of showing something is not recognizable?
Yes. So the same method of showing undecidability works via reduction. It's exactly the same for not recognizable, but you start with something that's not recognizable.
So you start with something that's
Yeah.
not
So remember, like for the undecidable stuff, we did a reduction from something undecidable to something we want to show undecidable. Same thing here, from not recognizable to something not recognizable.
Oh, okay. We don't have too many unrecognizable machines that we already, languages that we've proven.
Well, one of them was ATM bar.
Yes.
Yeah, so that's one of them. So that's one of them already. How about this? So how about I make up a problem?
Yeah.
Okay. So call ATM self-knowledgeable. Let's call the machine M. If the language of M is exactly its own description and nothing else. Oh, yeah, it is.
Hey, I'm working here somewhere. Yeah, the other one. Yeah.
Why did you tell me?
You know what happens?
You have to try.
Stitches, dude. But that's problem set. It's not.
Snitches get stitches.
Right after class.
Well, one I know is not recognizable is EQTM. Yeah, so this is not recognizable.
Is it an easy to prove kind of thing, or is it a bit complicated?
Yeah, it's pretty easy. So another problem that's not recognizable is ETM. So we'll do a reduction from ETM to EQTM. I think we already did that, but it bears repeating. So the same type of reduction works here. So suppose R recognizes EQTM, and then we'll try to recognize ETM. So Rice's theorem doesn't say anything about whether it's recognizable or not. So, but if I show this, then I'm assuming that ETM is not recognizable.
So
I can actually prove that in a bit, but yeah.
So you want to look for some way to show that it recognizes when it has an empty one, you're saying? So like you can just say if two empty ones would be equivalent, like something like that.
Well, not two. You want to have feed M and some other machine into a supposed recognizer for EQTM. Okay, so what was the method we saw to show that EQTM was not decidable before? Well, what we did is we made a machine that accepted nothing, had empty language. And then we said, feed the original machine and the one you just made into the supposed recognizer. And then if it says yes, then that must mean that the original had empty language, right? And since we only care about acceptance here, we don't care of whether it runs forever, yeah,
Would you be
on
able-
things and not in the language, yeah.
Would you be able to do something involving ETM and not ATM? Since not ATM would be.
Yeah, there's another way to prove that. The ETM is not recognizable though. Yeah, the problem with ATM bar is that you have to work with inputs that are not necessarily of the form MW. But you just say if it's not of the form MW, then accept because it's in the complement. So then you have to worry about you want to make a machine that has empty language exactly when M does not accept W. And the book has a proof of that. Yeah, so I'm not going to go over that here. So like in the idea, we're going to make a TM M prime with L of M prime, empty, and then run R on M and M prime. And if R accepts, we accept. We accept R. And here, since R may run forever, or it may reject, I don't care about those strings. No, I don't care about when that happens, because I only want a recognizer supposedly for ETM.
So you don't even have to say.
Yeah, I don't need to say about when it doesn't accept, because R may outright reject, or it may run forever. I don't know.
It might, in the last homework or whatever, but on the other cases, we don't care because.
For recognizer, yeah, you only need to worry about the strings in the language. And the recognizer supposedly halts on those. So, yeah. But then since we know ETM is unrecognizable, EQTM also is.
So does that mean that you can not only can you not decide whether two like programs, for example, are equivalent, you can even like see if they're close.
I can't even make a program that works for machines that really are equal. Yeah, which is quite unfortunate. So, what is a proof that ETM is unrecognizable? Because I can't just wave snake oil in your face and just say, oh, this definitely works, right? I better prove it. So what if I prove that ETM bar is recognizable? If I prove that, then could ETM by itself be recognizable? Well, remember the result that we showed in class. If something and its complement were both recognizable, it's decidable, but we know ETM is not decidable. So if I show ETM bar is recognizable, there's no way that ETM itself could be recognizable. Okay? Well, let's see. Could I verify whether the input is not a valid Turing machine encoding? Yes, certainly. Right. If it's just malformed, I can definitely check that. So the only thing we need to check now is, does it actually accept anything? Well, use the run in parallel idea we did before. Run the first I strings for I steps. And then if it accepts anything, it will accept one of those strings at some point. So we can recognize ETM bar just by running the first I strings for I steps, and then just keep increasing I as we go along. Okay? So that's a proof that ETM bar is recognizable. ETM by itself is not recognizable. And so therefore EQTM is not either. It turns out that EQTM bar is also not recognizable. But we can't prove it this way because I can't just reduce ETM bar to EQTM bar, because ETM bar is recognizable. But so that definitely won't work in general. But I'll leave it as an exercise to figure out how do you prove EQTM bar is also not recognizable. The proof's in the book, but try to think of how you would prove that. And the hint is to use ATM bar for that. Yeah.
For the for recognizing EQTM,
Mm-hmm.
we didn't mention ETM in there anywhere. Is that just implied?
Yeah. Yeah. The outer machine that we built was a supposed recognizer for ETM.
Okay.
Yeah. Remember that.
Recognizer for ETM on it.
Yeah. No, we were able to build this supposed recognizer using the supposed recognizer for EQ. Because we assumed that R recognizes EQTM, then we just built this recognizer from that.
Oh, right. Okay.
Cool.
So that's in place of the where every other time we've written to recognize ETM. That was implied.
Yeah, yeah. Yeah, so we're doing a reduction from ETM to EQTM. Yep. Other questions? Yeah.
On the roller coaster,
You don't get to say that often, do you? Okay, cool.
I
Yeah.
honestly have no idea what it's
Mhm.
asking.
So it's saying that, so here's my attempt to draw a roller coaster tycoon grid. Okay, so suppose that we have a path going right here, and then there's a gap, then there's some more path, maybe it goes this way, then maybe there's another gap. And then maybe there's some other tiles here. And so there's a start place, so now I'm going to try to draw a gate. People on YouTube are going to be like, what in the world is Ryan doing? So you have this starting place, which is a predefined cell, let's say, of the grid. And then there's a and there's some predefined finish place. So maybe another cell of the grid. The problem says you're given this game as is and an integer k, and the problem says, is there a way of placing k tiles such that there's a path from the start to the finish? So like if the answer was, let's say the finish was right here, and the start is right here. Well, I can place, let's see. You don't have to worry about placing a tile on start and finish. So I can get there in 2 more placements of tiles, right? So I'll put those in a different color. So I can place that tile and that tile. But I can't get there in 1 tile. So I'm asking, given this arbitrary roller coaster tycoon grid and k, which is an arbitrary number, can you place k tiles so that you can reach the start to the finish? And that question I'm asking is NP complete. Okay. What's that? Yeah, it's kind of like the Mario game. So can you reduce some NP complete problem to this one? And also show it's an NP.
Can we use the Mario game? Is that like an acceptable problem? And as we learned at the end of class, the Mario game is NP.
It's just how would you convert it though?
Well, I mean, it's like a 2-dimensional game. It's like a 2 versus 3D game.
Yeah, but it's just that the structure of a Mario game can be arbitrarily complex. If you can find a way, that'd be
But
good.
I mean, if we use the building blocks you showed us the other day.
Yeah, but
2D
but remember, it's an arbitrary Mario grid. It may not necessarily be of that nice form. So you have to take an arbitrary input of some problem and turn it into an instance of this to show it's NP hard.
But isn't that arbitrary as well?
No, I'm reducing from some problem to this problem.
Oh, okay.
Yeah. So think of the NP complete problems that we worked with. CNF SAT, 3 SAT, CLEAG, independent set. So I highly advise using one of the SAT ones because those are the big daddy NP complete problems to reduce from. So you're given a formula and you want to transform it into a roller coaster tycoon game. Okay? So that the formula is satisfiable if and only if there is a way to place k tiles. And you get to choose the value of k based on the original formula. So if you look back at the, way back, if you look back at vertex cover, we defined k to be n, which is the number of variables, plus 2m, which is the number of clauses. M is the number of clauses. So when you transform it over, you can define the k value. Yeah, so that everything's valid. So I highly advise making a variable gadget, which remember has only 2 possibilities, right? So it can either be true or false, and then connect them up in the same way that we did the Mario game. Okay? Yeah, so remember we had, in the Mario game, we had these variable gadgets, and we connected them up to the clause gadgets. And we had a clause gadget that that only works if and only if there is some variable connected to them to make them true. And the only way we can make the formula true is if all clauses are true. So I highly advise making a variable gadget and have a path that streams through all those, the output of all those. This problem is not meant to be hard, but it just sounds hard.
How does it not relate? I'm so confused as to
There is, I claim there is a reduction from Mario to that one, but the problem is that you can't guarantee much about the structure of the Mario game.
But, so, we can guarantee though that he has like this one path both ways.
No.
But
You can't guarantee there is a path.
didn't they create the gadgets and
No, the input is an arbitrary Mario game. Arbitrary. It's not of a nice form. It doesn't have these variable gadgets or whatever. It's an arbitrary game. Then you transform it into, based on that, into a problem in the other domain.
oh jeez, okay. So like
Yeah.
that's like saying, you know, level 1-5 and transform it into a roller coaster tycoon, right?
Or no, an arbitrary level. Arbitrary. So like here, we transformed an arbitrary formula into a graph. We didn't assume anything about the structure of the formula other than the fact that it's a 3-set formula. That's the only thing we assumed. Okay? So,
I think you should definitely say Mario.
Yeah.
okay, so to answer your question, if we go all the way back. So, something that'll really help. If one of the clauses is not true, so let's say we're reducing from 3-set. If one of the clauses is not true, is the formula true? No, there's no way it could be true, right? So you want to make sure that there's some path, however you design your clause gadget, there's some way for the path to go through them in some way, such that if you satisfy every single clause, then there is a way through. And if one of the clauses falls short, then there's no way through, right? Because if the formula is false, then there should be no way to get to the final destination. So the idea here is, remember, variables have 2 possible outcomes. So I'm going to go all the way back up. When we did the simulation in vertex cover, there were 2 possibilities of each of the variables. So model that in some way as paths so that you are guaranteed that there's only one way, one possible choice you can make of path. So have it so that there are 2 choices of paths you could make, but make sure you can only make one of them. And you enforce that by making k small enough. Just like in vertex cover where it was precisely the number of variables plus 2 times the number of clauses, we guarantee we must pick exactly one of the variables in order for us to actually get those edges up there. Yeah.
So you probably then would recommend us tackling everything on a single, like the z coordinate instead of going.
Yeah, I wouldn't. The problem, because we're doing the 3-set, connecting them up, the problem is that you'll have crossovers.
Yeah.
So you need a crossover gadget. But I argue that that's not hard. So how do you make 2 paths cross over each other? Yeah. Yeah, remember
But in relative, I haven't played it.
Yeah.
So don't crucify me. Is it, you can go up 2 levels in one.
No, you can only go up 1 in 1 tile.
So you
Yeah.
need to cross that, you need at least then to go up 2,
You need to start 2 ahead, yeah.
Okay, so if you don't have 2 spaces, then you're not able to.
Yeah, but remember, you're making the grid. You're making the game.
Oh, okay.
So you can have that happen.
Okay.
Yeah. You're taking an arbitrary input, but based on that, you're making the game.
I see.
Yeah.
So we make our arbitrary input work for us as long as it covers those spaces.
Yeah. No, all bases.
All bases. All bases.
So if you happen to reduce from 3-set, then every formula can be transformed into a game. And the answer of whether it's satisfiable is the same as whether there's a path. Placement of k tiles. Okay. Other questions or more about that?
How do you feel about transport?
I haven't played it.
Oh.
Wrong answer.
I love that.
Yeah. Chris Sawyer's a genius, though. There's reports that the original Roller Coaster Tycoon had 3 million lines of assembly code, handmade, because he wanted to optimize for the computers of 1999.
It's the only way it would run.
You know, it's the only way it would run. So, and if you look at the back of the CD, there are like requirements that the computer must have at least 32 megs of RAM. So,
That's why they can get it to run the iPad now.
yeah.
At least it's not like locked on the actual CPU.
Yeah. If you look at something called Open Roller Coaster Tycoon, it's something I've been following. They're making the game much cooler. They have like online servers now, so you can look at other servers and do multiplayer with Roller Coaster Tycoon. It's pretty insane. You can make your own custom roller coasters. You can do cheats, everything. So Open Roller Coaster Tycoon, I highly recommend it. Other questions? No other questions? We can call it quits early, unless there are other questions. Oh, I should say, nothing on Friday will be on the bonus question for the final exam. So it's just kind of like a relaxation day.
And the bonus is worth 55 points?
Yes.
I have a quick question. How is the 5 questions that you removed from the?
Oh, yeah, okay.
Is
So
that now 950 or is that still 1,000?
no. So the idea is, I'll probably mention this on Friday because I guarantee more people will ask. But the idea is take your 30 non-bonus problems. So ignore bonus for a second. 30 non-bonus. Remove the 5 lowest, so you have 25. So the total score is out of 250 right now. Multiply whatever you have by 30 over 25 to scale it up to 300. Then add the bonus points on top.
Okay.
Yep. Yeah, so now it'll be possibly more than 300, but really out of 300.
Okay.
And then midterms and final replaces the midterms if you do better than the midterm.
Is that raw score or is that after curve?
What do you mean this?
The final replaces the raw based on raw score?
The curve score.
Curve score.
Yeah. I mean, it only helps you.
Yeah.
So, yeah. Depending on how final go, I may curve it. I don't know. I don't want to introduce bias if I can. So.
Okay.
Is there a curve on the whole class? Or the letter grades that exist just based on the points?
Well, if I did a raw curve, then people would be disappointed for sure. No matter how high the average is, the middle is a C.
Yeah.
That's what a curve is. So I'll discuss the strategy I'll do.
Trying to figure out.
Oh, I thought you did do it. Did you reduce or something? Did you reduce the percentage or something for the grades?
Yeah, that's not a curve though.
Oh, okay.
Because I uniformly decrease those.
Okay. That's
Yeah.
what I was wondering.
Yeah.
It's just weird because the percentage doesn't match up to the letter grade. That's what I'm thinking.
Oh, I should fix that. The letter grade in your grade center doesn't match with what I said. Yeah, I forgot to update that. Thank you for letting me know.
I was gonna ask, and this is probably too much about the test, but the space, is that as important? I know this is beyond what the
Yeah.
the
Mhm.
questions are, but
Yeah.
is that something that
So,
we need to focus on?
I would probably not worry about space.
Okay.
Probably just NP complete.
Then be complete, so we get that down, we understand this, we
Yep.
knock out problems at
Yeah.
5,
Yeah.
weird goal.
Should be.
In theory.
Yes. Well, it's a theory class, so. Other,
Currently, I'm like, what the percentage is like the actual percentage out of the points.
the currently earned points for you only. Yes.
Okay, yeah.
Yeah. Because of some exemptions and other things, some people have fewer points, but a different percentage.
Okay, and then the letter grade would be like with respect to
To your percentage, yes.
Okay, with respect to my percentage. If
Only.
it were to end right now, that's the
Yeah.
rate we would-
Yeah. Although he says that it doesn't quite match up, so I need to fix that.
I mean, I'm just gonna.
Yeah.
So
Other
the
question?
letter grade that we have right now, it's not after you drop the lowest.
Yeah. So that's currently raw score.
It's the
Yeah.
lowest.
Yeah. So it can only help you after this.
Can only go up.
Yeah.
Well, like for instance, I was in mine, so it's like percentage, like 9.
Yeah. It's
Because that's like out of percentage points, but remember, it adds 95% because an A plus is at
okay.
8.
So is it correct then?
I don't know.
I'll recheck.
Because like, what is the plus like
90 up.
From 90 up.
Yep.
Yeah, so if you had,
Oh, really?
Yeah.
Oh, okay, yeah, so then it is.
Okay. Good.
yes.
But I'll recheck anyway.
Okay, makes sense.
Other questions? All right. I'll see you on Friday.